what we have next. Okay, so we learned the three basic parts of the neurons. Now let's try the three types of neurons. Okay, so there's three basic types of neurons. I want to let you know that if you took a more advanced class later, that you would see that different neurons have different shapes. So I'm not talking about these are the three shapes of neurons. I'm talking about that these are the three basic types of neurons. So neurons can have different shapes, but here we're focusing on the types. The first one that we have is we have a sensory neuron. So it's very easy to remember this one, sensory neuron. It takes in information from the senses. So what are our senses? They're vision and smell and touch and hearing and taste. So all your taste receptors would be sensory neurons. Your visual receptors would be sensory neurons. I think you understand that. Okay, then we have an interneuron. An interneuron is a neuron that communicates in between neurons. So a sensory neuron never directly communicates with a motor neuron. There's always going to be an interneuron in between the sensory and motor neurons. Let's see what the motor neurons does. If the goal of the nervous system is to receive and transmit information, help the body interact with the world, communicate with the outer world and the inner world, and function in it, the sensory neurons take the information in from the senses. They grab the information from the environment. Then they communicate with an interneuron, and then the interneuron sends information out to the muscles and says, okay, this is how we want you to interact with the environment. That right there, that pattern of neurons is sensory neuron, takes it in, communicates with an interneuron, and goes out to a motor neuron, is what we call a reflex arc. So in all reflexes, what you have is you have sensory, communicates with interneuron, communicates with motor neuron. That's exactly how it works there. Sensory, intermotor, sensory, intermotor. That's a reflex arc. That's how things work. Okay, so those are the three basic types of neurons. Let me just ask you something. I want you to think for a minute. So, if you had to tell me which nervous system I would find most interneurons in, what do you think it would be? I'll let you think about that for a minute. Let me just give you your choices. Would it be the central nervous system? Would it be the peripheral nervous system? Would it be the somatic nervous system, the autonomic nervous system, sympathetic, parasympathetic? Okay, hopefully you had a chance to think about it. So the answer would be the central nervous system. See, most sensory neurons and motor neurons are located in the peripheral nervous system. And so, of course, you would know that the peripheral nervous system encompasses the somatic nervous system, autonomic, sympathetic, parasympathetic. So most of your sensory and motor neurons are located all on the outside. And where most of your interneurons are, the connecting neurons between the sensory and motor, are in the brain and spinal cord. I think you guys can probably visualize that. Alright, we finished that objective. Let's go to the next. Alright, how do neurons communicate? So, neurons communicate through neurotransmitters. So let me go back for a minute. Let me repeat it again so you get to write down this thing. Neurons communicate through neurotransmitters. So if we go back to this slide right here, the dendrites carry the information in, the cell body takes care of the cell, and then the information gets transmitted down here. So these presynaptic terminals at the end of the axon, they are going to release the neurotransmitter. There's storehouses right here called vesicles, and they store these neurotransmitters. Neurotransmitters are brain chemicals. When we have an action potential, a stimulus causes this cell to react, they release a neurotransmitter into a gap called the synapse. And all around here, you'd have other neurons. So there's a gap right here, and you'd have lots of other neurons over here, and they would get the message. So the message is released in the form of a neurotransmitter. Okay, let's go back. Oops. So here, what you have, I'm not going to focus on the action potential too much. Now, you can read in your textbook, but even in your textbook, he doesn't spend much time on it. I feel for the Psych 1 level that maybe it's best if we just talk about, okay, some stimulus causes a reaction in the neuron. Okay, so in this picture right here, the dendrites would be up here, then we'd have a cell body here, and then the axon would come here. So when we get some stimulus up here that causes this neuron to react, the information travels down the axon and it causes the terminal vesicles, right here, to release a neuron. The synapse is the gap, okay, and it would send messages to other neurons that are located all out here. So what's interesting about that is all of your thoughts, every thought that you think, every feeling that you have is just a neurotransmitter being released. It's just a chemical being released. So let me go through. I don't have these on the slides, but your book does have a list of the basic neurotransmitters they talk a little bit about. So I want to talk to you about them so maybe you can understand. So for example, serotonin. Low levels of serotonin has been linked to a depressed mood state. So if you are not having serotonin released for whatever reason, then it seems to be associated with depression. If we have a neurotransmitter called dopamine released, then a lot of times when dopamine is released, it causes these feelings of pleasure or these feelings of satisfaction. And so almost all addicting drugs, the way they work is they act like dopamine, or they cause more dopamine to be released. So now you put a drug in your system and all of a sudden you feel great because you're causing the receptors that react to dopamine to be activated, or you're causing actually more dopamine to be released. So when you feel pleasure, it would be dopamine being released. And I'm simplifying this greatly. And maybe when you're feeling sad, it's because of low levels of serotonin. When you're feeling anxiety, it could be higher levels of maybe glutamate and norepinephrine, epinephrine. There's many chemicals related to anxiety. We have something called endazepines. But basically what I'd like you to get out of this slide right here is that every thought that you think, every emotion that you have, is just chemicals being released. And to me what's great about knowing that is it allows me to step back sometimes. It's really hard, but sometimes when I'm having some kind of negative mood form, if we can step back and say, this is just chemicals being released. This is not really it. And then another thing is you say, okay, these chemicals are being released and they're affecting my mood. Now what can I do to change the chemicals that are being released? And think about it. What are some things that you could do to change the chemicals that are being released? Well, if you start exercising, we know exercise is going to cause a certain release of chemicals. I think a lot of you, although it's possible definitely to cry while you're running, I've done it before, and it's possible, and it's possible to have negative feelings while you're running. Even when you're exercising, it seems to change things a bit. If you turn on a funny movie and distract your thoughts and start watching the movie and start laughing, that would change the chemicals that's being released. So by realizing that all of our thoughts and emotions are chemicals being released, we can kind of realize, all right, my brain is saying this, however, the actions that my body take can influence the brain. The brain does not have the final say. The brain and the body are always working together.